This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, we're going to get started today. We are going to continue our conversation on we're going to continue our conversation on tectonics, new tectonics, and specifically kind of also looking at a recent history of that moment, focusing on a specific edition of Architectural Design magazine, edited by Greg Lynn, architect Greg Lynn. And then we're also going to, finish looking at examples from last Wednesday, and then some examples of surface in architecture, but also this idea of a performative surface. It's not just the stress on topological in terms of a formal-driven architecture, but one that also has a type of performance value to it. How does it improve the building or the space in the building? And we'll look at a couple case studies on that. Next week, on Wednesday, we're going to look at the idea of program in architecture and how that is a driving factor in a lot of designs, and also how that could be understood as the original to think, I guess you could say, as one way of thinking about systems thinking in architecture, and look at some case studies about that. But on Friday, I'm going to give a lecture on manifesti and architectural treatises. And that is just one lecture that's going to be dedicated to talking about this topic. And it's very important because that's one of the major assignments for the subject is for you to create your own manifesto. So I'm going to give a little history, look at some architectural manifestos, and talk about the criteria and how you should start thinking about that assignment. Because then the following week you have an outline due. Okay? So, where were we last week? On Wednesday, we stopped with Toyo Ito's Serpentine Gallery Pavilion, and with the idea that most pavilions are pure tectonics. There's no other real program other than architects kind of show off this tectonic expression. And this one, it would have been able to be brought about, I guess you could say, without the use of computer, but it would have been very difficult to be derived without the use of the computer. Also, with Toyo Ito and a lot of these avant-garde, I guess you could say, that are kind of pushing this new type of tectonics, they're always paired with a structural engineer. And Toyo Ito did this project with the structural engineer Cecil Baumann. And then we'll see another project where he paired up with. So Ito wants to push the boundaries, his tectonic boundaries, but he has to do it in a close collaboration with the structural engineer to see, what will work, what will not work, and that's fine. That helps. It's not just this idea of the sole architect. It needs to be this kind of collaboration of expertise, but then to drive architecture forward. And so, just to go through how Ito and Baumann came about this form. They started off with this seemingly chaotic assemblage of lines. But in reality, the way that Ito created that was kind of like looking at these different types of spiraling patterns and where he starts off here just kind of overlapping and skewing two squares, and then adding another square on, as you can see here, and another, this kind of spiraling inward pattern, and then extends out the edges of these squares into almost like a type of mat. And so that he takes that pattern that's created through just these skewing of different squares and extending the sides out, and then he wraps it around this kind of rectilinear volume or cube. And those are just the kind of thin framework members, but he doesn't stop there. He then goes on to decide, he gives these frameworks some depth. And with Bauman, they decide, and figure out which ones, and what he's doing here are making a box frame construction. And so they have these individual members, which are both columns and beams, but then by adding strength and making these into box frames, I don't know if you can kind of see this here. These are basically metal panels that are patched in and sandwiched in amongst some of these beams. And then some are these kind of box frames, and then some are just open to the air. And they don't need any. But there's just enough to give it, this structure stability and strength. And this idea of kind of sandwiching in the beams with two metal plates is something that, again, comes from outside the discipline. That's how a lot of, structures and boat hulls are made in naval architecture. And so they take this technology and see how it can be used in architecture in this simple pavilion. And here you see it. Most pavilions don't have a program, but here they've turned this one into a cafe. And those open spaces, which weren't needed to create a box structure, are letting in light and air and so on and so forth. There may be glass above there, I'm not really sure, but not needed, especially not structurally needed. And you can see how that's like a precursor to this next significant project, I would say, of the 21st century. And this is Toyo Ito's Sendai Mediatek in Sendai, Japan. And it was completed in 2001. Wait, is that correct? The project may have started in 2001. Yeah, 2001. And Ito's initial, I guess you could say, design intention was to kind of make almost like an aquarium, this kind of glass block, and what would appear as like a very delicate glass block, but with then these kind of columns that would be almost seem as if they're kind of floating, and or pieces of kind of floating seaweed. So he had this intention, and working with the structural engineer came up with this design which won the competition. And this is just some basic components. You could say it's a glass built, curtain wall office building, but it's the way that certain things that Ito decides to focus on that really makes it quite special. Not as in it extremely resilient to earthquakes. It survived, what was it, in 2004, or probably maybe a bit later than that, a quite significant earthquake, with the only damage really being some of the suspended ceilings coming down. But he's basically based it on these few simple elements, but then drove some of them to create something new. It's really just 6 linear planes with the interior design also done by different designers. So they're given a little bit of a different style or effect. There's also this glass external skin, But also that's not the same all around. The different floors and different elevations have different treatments. Sometimes it's etched, sometimes it has a pattern on it. And this is what is also quite significant. There's 13 reticular columns. And this is where it's also very innovative, with 4 of them, quite the largest ones on the 4 corners to prevent any kind of torsion going on. And then also the 9 others, smaller, interspersed throughout this kind of square cube of a building. And what is interesting in these spaces is that they're not just columns, because they are reticular, and they're designed a special way. It allows for, well, Ito has put in these spaces these kind of hollow tubular columns, which are not also one continuous shape going up, but they change shape from floor to floor. It's also a space where he's putting in the programs and program space and services like elevators, ductwork, the electrical, the cabling, and even these function, as you can see here during the day. There's a light shaft up above, a skylight, and up at the top of these columns are automated, they can be like remotely controlled set of mirrors to then also direct light into these spaces. So again, this is, this epitomizes what I'm talking about as performative. In addition to being performing as the structure, they're also this kind of a light mechanism, letting light get down to the bottom of the floor. Also space for containing alternate, other services of the building. And that also then freeing up space where people can occupy space and, getting to this expression of lightness of these floating planes, right? Because if you don't need the services in the ceiling or in the floor, you can make that floor slab quite thin, right? And so it's freeing up the other spaces. And so it's performing in these, you're kind of building in stuff into these spaces and adding more and redefining what a column can do. Here's what it looks like during the day. And he didn't want it to look weightless. And actually, I have a pretty long quote here describing Ito's intent. And what I also like about his description of the process is, he said, at first I wanted to do this, but then my idea changed. And I admire that because it also shows his ability to change his mind and have this as, I guess, evolve, have the project make him evolve as a thinker. Also, what makes this more than just, I think, a glass block building is the ability with the structural engineer Matsuro Sasaki is to make these incredibly thin floor slabs. They're only 40 centimeters thick, and they span 20 meters wide. And they're able to do this by using the steel plate sandwich that we saw that was being used in the pavilion. And it's only then that you can have this quite rigid floor plate, but thin as possible. And also what this does is, I don't know if I have the image here, but it allows from the outside, even just looking into this building, you're seeing very much all the different types of ceilings. So it's something that we never even really think about, or as architects, or we don't get to at least as students, is the importance of what a reflected ceiling plan looks like, and how you're looking through this transparent glass, and so that became an important design distinction, and it also gives distinguishing characteristics to each of the different floors. Here's a look at these columns and how they were adjoined to each of the different floors. And if you can see here, this is basically almost like a circular I-beam with these structural tubes attached. These had to also, a lot of the columns had to be prefabricated prefabricated off-site and then brought to there because they were such a custom and such precision was needed. And here you can also see how the glass, or at least on this one elevation, it's kind of extending off from outside of the building. It's not jammed up on top of it. It's not part of a mullion system, but it's just kind of like hanging there off of the floor slabs. I don't know if you can see that detail there. Here's just, that's one of the images of one of the reflected ceiling plans, but they're different for each different floor. And we'll talk about this in the coming weeks, but the reason why you can also have this glass facade that's basically literally hanging off of the building, and this idea of lightness and transparency of structure is not only because of these very thin 40-centimeter steel floor plates, but something that goes back to Le Corbusier, right, and his idea of the free plan, where you don't see any of the structure from the outside, really. Or you see it, but you're not even really sure that it's the structure, these columns, right? And this is something that students misinterpret, I think, sometimes when talking about Le Corbusier's free plan. Free plan does not mean free space or open space. Free plan is because the structure is freed from the facade. And so you can step away the columns in, for Le Corbusier it was a regular column grid, but the two do not have to be, are separated. And you have a lot of freedom to put the column or in that column grid wherever you want, away from the exterior of the building. But you do see them, but they're not easily identified as the structural component. These are just some sketches by, I think by Ito, showing also from each floor, as you can kind of see here, each span from floor to floor of these columns are also different, and they create a little bit of a different floor plan in each one. These are just some of the structural drawings, and I guess the basic form that the structural engineer started out with was with a hyperbolic paraboloid. Here's some modeling of that column there. And just, again, showing you the different floor plans and construction. This is some images of how they were during the construction process. Here you can see this kind of almost like a circular beam. Here they're pouring into the slab, but I think I have another image of the kind of sandwiching. But this is the quote by Ito. I'm sorry, it's broken up into 2 slides. It's a bit long, but I think it's quite interesting. He states, "The fluid nature of the floors is something I always aim at, but I didn't want the building to look immaterial, not at all. By exposing the materials and the structure, I wanted to show people that these materials actually support the building." Architecture always has to deal with the challenge of gravity. That's something that hasn't changed in the course of history. However, by changing the structure, we have to create a quality of space that matches the present time. And mind you, this is a media tech, right? It's a media center. People will be using the computer and different technologies. And so, anyway, I'll continue the quote. "Before I tried to hide the price of withstanding gravity. Now I feel I can expose these materials, have them out in the open, and still create modernity that responds to what is going on today. That's a major change. We architects have to provide bodily experience through our creations. In the past, I tried to construct something that is weightless, like society itself becoming increasingly weightless. Nowadays, I feel that even in this information society, we still have gravity. We still have to feel it, so we have to reopen and establish the awareness of gravity again." And so, I think this is also he's noticing this general trend of the use of digital technology in architecture and just in our daily lives. He said, initially kind of going for this immateriality, but noticing that so much in our lives is about the immaterial. Why would you want to make an architecture that is also immaterial? And in the end, I think it's very light, it has different properties, but he's like, let's celebrate, the materials, not make it just disappear, because there's so much other part of our lives, even our labor, right? We're not even making things anymore. We have this idea of now immaterial labor, so that when you do have concrete things, so things that, have to withstand the laws of gravity and structural load, celebrate that. And we'll look at that also when we talk about transhumanism and artificial intelligence. It would make you think that architecture becomes, or the body becomes, less important in architecture. But if anything, it almost is a reverse, a reevaluation of what it means to be human. And then looking again at and reevaluating the human body and what that means for architecture. So yeah. And just one thing also that I find interesting about this building, it's this idea of locating the services, a way to clear up the space for the program is not new. I mean, and a certain precedent would be Louis Kahn's Penn Medical Towers in Philadelphia. They don't exist anymore, they've been torn down, but if you can see here, this is just an image of them. They're not, that spectacular in terms of the exterior, but if you look at what he was doing in plan and also in section, these are laboratory spaces. And so he wanted them to be column-free, obstruction-free, and so he pushes to the exterior of the square, the elevator and the staircase. I mean, there's also a central one here, but also these different towers, each has a different one. Here's some other images here. Oh, I don't have a section, but in between also the floors of this building, there's also like a plenum space where all the electrical and ductwork would go as well. So both in plan and in section, it's kind of service, hopefully you learned this in modern architecture class, but this idea of service and served spaces, right? The served space is the laboratory that you kind of want free from all these surfaces of the building and maintenance interrupting what you're trying to do, and the served space are, it's basically like a little crawl space between the other floors. They also exist in the Salk Institute as well. Anyway, but what Ito is doing here is now that same concept, but putting the services in the reticular columns. Here's like the column with the air conditioning ducts in them. This is looking down one of the columns. This is just mapping out where the structure needs to go, structural forces. Here's just a detail of some of the columns. Here's a stair. Here, I don't know what some of those other ones are. But here's also an image of the beams, not unlike what was going on at the Serpentine Pavilion, where you have the steel beams here, and then welded on top are these metal, steel plates. And it gives it, quite a rigid frame so that you can get that thinness of the floor slab. Here's another image of that. Although there's some images of, it looked like they have reinforcement, so I don't think this happens on every floor necessarily, but this one you can see here, same thing. Here also on the top floor, this kind of floating brise-soleil, and here you can see the different treatment of the windows on each floor, and you can also begin to see a little bit, here it's etched, here you can see some views of the column going up, here it's solid. And then, yeah, even looking at this one corner detail, here you have this glass facade hanging off with some type of etching that acts as a screen. Here you have etched, but vertical slats, and this kind of floating ceiling with different types of lighting and the brise-soleil on top. So there's different variation. I think, yeah. So that was an important case study. Now let's go back, though. And that, I think, yeah. Let's look at 21st century cladding, or at least this kind of emphasis on topology, right? The architecture of the surface. And what I call folds and blobs, because it kind of goes back to this first, I guess you could say, if you want to trace back the beginning of parametric thinking in architecture, it starts with this idea of architects looking at this critical thinker, French thinker, Guy Deleuze, and he wrote this book on the fold. And a lot of architects, especially Peter Eisenman, even though these texts and these philosophers weren't celebrated in France when this first came out in 1988, in the United States, these theorists in comparative literature, but also in architecture, kind of grabbed onto this and sought this critical theory as a guide and to kind of use as a strategy for thinking about design. Some architects, because you have postmodernism, you have then deconstructivism styles, I guess you could say, which was also very short-lived. So architects were looking, and you really didn't have the total embrace of the computer yet. And so architects were kind of looking for this kind of critical theory as a guide for some of them, not all of them. And it's something we really don't do anymore. It was like a moment in time where I guess you could say the isms in terms of styles kind of ended out. Now there's definitely a plurality of ways to and priorities in architecture, but also you can say the stakes are higher, right? Architecture cannot be reduced to a style if it's going to, matter in society. There's other goals, and a lot of architects think that those moments of postmodernism or deconstructivism were a waste. It really led the discipline astray. In that there were other issues we should have been tackling, like sustainability. But anyway, some people, maybe there's a loss. It feels like there's a loss because there isn't one thing that is known what to do today. Patrick Schumacher, who is perhaps one of the biggest proponents of parametrics, and he's termed the phrase as a style, parametricism, and he's an associate and now probably the head of Zaha Hadid Architects. But it's not something that can be applied wholeheartedly to every type of design. But anyway, let's get into what are architects looking at? What do they mean when, the fold? What was the fold? Well, it was this philosopher looking at especially a lot of Baroque architecture, and specifically this sculpture here by Gian Lorenzo Bernini. If any of you have been to St. Peter's in Rome, there you would see this sculpture here. It's in top of one of the crypts, and it's a very famous sculpture. I mean, the Renaissance basically skipped Rome, but when the Baroque came along, I mean, that's where it just bloomed. And anyway, Deleuze is looking and talking about this sculpture as kind of as a means as a vehicle to describe what he's talking about, this theoretical idea of the fold. And so I'll read this quote. And when the folds of, and he's talking about the sculpture, when the folds of clothing spill out of the painting, or a painting by Bernini, it is Bernini who endows them with sublime form and sculpture. When marble seizes and bears to infinity folds that cannot be explained by the body, but a spiritual adventure then can be set the body ablaze. So to experience in the Baroque is to be outside and inside at the same time. So this phenomenon, this paradigm of, of the fold in architecture. And so some architects interpreted this as literally like, oh, that means we should like look and understand folding, and I look at fold, or the form of a fold in architecture. Whereas some of them understood, no, you not take it literally, but that this idea of folding that Deleuze is talking about is in fact a process, and it's not a form. And it's not a process of visual folds, but one which form induces the perception of motion or animation through this idea of continual variation of a surface in architecture. And so I talked about that a few weeks when we're talking about the Bezier curve, and how Greg Lynn is the kind of continuation of that. And the bolt hole in naval architecture, how it's this kind of curved, complex curved surfaces that anticipates motion and movement. Also, Deleuze in this book, the book was called The Fold, Leibniz and the Baroque. Deleuze also kind of takes a re-examination of Gottfried Wilhelm Leibniz. Who was Leibniz? Well, he was a German polymath. He was, a mathematician, an inventor, and he was a philosopher of the Enlightenment. If it wasn't for Leibniz, we wouldn't have the differential calculus. And I'm going to explain to you why that's important, not only for Deleuze, but especially for architects at this moment. Also, what architects were taking from this text, so it's Deleuze writing about Leibniz and architects reading about it, is this concept that Deleuze talks about of the object event. And this is something that is taken almost literally, and I will show you some other examples of this. And it's the breaking up of the Cartesian grid and the perspectival grid, right? We've talked about the Cartesian grid, right? X, Y, and Z, right? Coming from René Descartes. It's an Enlightenment invention. But now architects are interested when Deleuze is saying, we're going to, there's a breaking up of this Cartesian grid, also perspectival grid, this kind of even, one vanishing point. And instead, it's about creating and morphing these grids into this idea of continuous variation. Now, you've heard Greg, and I'll go over it again, but Greg Lynn's interpretation of how this continuous variation is created through a parametric curve that's weighted according to different variables or parametric rules that are set into the curve. But I'll show you some other architects' interpretation of this kind of morphing or morphogenesis or morphing of the Cartesian grid. Oh, sorry, this is just this is exactly what you would imagine Leibniz looking like. This is to give you his lifespan, 1646 to 1716. This is what we're talking about. But, it's quite interesting that architects, in the early to late 90s, such as Greg Lynn, are still finding inspiration for architecture from this. Just also, when I say he's an inventor, and some of his contributions to mathematics other than differential calculus, is that he's also creating, early, you could say even early computers or, early calculators. He invented this thing called the pinwheel calculator or the multiplication wheel. And then something that's actually called the Leibniz wheel. what you see here, it's basically this kind of cylinder that has all these different points where this gear moves across. I won't go into it, but it's because of the inventions like this wheel that, you can have, the next iteration of this is like a mechanical calculator like this one. It's based on this cylinder here on the Leibnizian wheel. So he's important. He's important to mathematics. And I read this quote out, but I'm going to read it again to tell you about why all of a sudden this differential calculus is important. And this is the quote by Greg Lynn. He's like, when he says, I realized that contemporary software packages could be animated because the geometric engines such packages were using were calculus-based. You can move an object and then interpolate a whole collection of variables into infinitesimally smaller steps. The points in space were fluid due to the calculus relationships of variables, and this was giving form and shape to the models. In my book, Animate Form, I focused my thinking on the revolution in motion and only later realized that the real revolution was in the use of a 300-year-old invention, calculus. And so it's also Lynn's ability to understand, at least this much about mathematics and relate it, and not only just know how to do mathematics, but understand the concepts and then apply them to create these different forms. And so, that led him to look at, animate, kind of these curvilinear forms in the Baroque. But as we know, and as his comparison shows, while these are showing movement and flowing of space, these are based on static geometries. These are not based on any type of, as you can see here, this is San Ivo in Rome. Static geometries. But anyway, so in 1993, Lynn is asked to edit, he is an editor of this special themed issue of Folding in Architecture. And actually, I don't usually buy magazines, but I was living in Italy, and I think it was in a bookstore, and I bought it. So I actually have the original, which is crazy. But also, it was reprinted in 2004, so you might be able to find a copy of it. But also, it's a digital copy you can get online for sure in our computer system, on the library system. And so it's based on this Deleuze's concept of the book, but and it's always cited within the history, I guess you could say, of digital computing as like this is the moment where architects really are starting to embrace, or trying to think theoretically about what are the could be the capabilities of the computer in architecture, also of a topological based architecture, one that's on this idea of smoothness and curvilinity. And now it seems quite normal, but this is new. 1993, this is new. But also ironically, and also Mario Carpo talks about this in the 204 edition, he has a small essay, there's not a lot of curvilinear architecture in this issue. And it was seen as like, okay, this is the next step after postmodernism and deconstructivism. I had some, this is seen as like, okay, this is the future. This is where we're going. And this is the first, architect or group of architects trying to take on this critical theory. But if you look at the actual articles and the architecture on it, it's actually, except for one project, which I'll talk about, it's actually not very good at predicting the future, or you know what I mean? But it's still, you have to kind of, it's almost like someone had to do it to get away from or to advance the discipline. So that's why it's still appreciated and was republished. So yeah, I'm sorry, just reiterating what I was saying. This was the first idea of a smoothness in architecture and how it could become a visual, this was usually a visual category created by theorists when they're thinking of, the picturesque in the 18th century, which this was also a product of a mathematical function derived from differential calculus. And so this is the first time a smoothness and curvilinear in architecture are happening with this issue. Also should just mention, it's a bit biased, but a really big recent study of kind of looking back into this moment and the beginnings of the digital in architecture was an exhibition, and it was a conference and a publication curated by Greg Lynn, and this was sponsored and held at the CCA, which is the Canadian Centre for Architecture, and it's this huge building in Montreal that is, just dedicated to architecture. They have fellowships, they have architects' archives there. So, Eisenman, I think, has his archives there, so it's appropriate that this is being held there. I think Lynn's selection are very much based in North America. I think he only has one architect, coming from Japan that is not based in North America, and that in that way, I think a lot of that archaeology should also be looking at the UK. But nevertheless, it's an interesting look at the beginnings of and how to get appreciation for computing and architecture. Actually, on your lecture notes, which are posted on LMS, I do have links to this because this book now is sold out, but it doesn't matter because everything that's in this catalog, which consists of 2 volumes, is on the link on the CCA website. And also there's videos there of interviews that Lynn did with a lot of participants and lectures by some of the contributors. So it's even better to read it online anyway. But back to folding in architecture. So it was, again, getting away from learning from Las Vegas, postmodernism, getting away from this deconstructivist and this short-lived moment in architecture. This is the kind of what this purpose of this issue served. Showing again this trend toward the curvilinear, examples of topological geometry, morphology, morphosis. It did look at computer technology, but not CAD, but looking at it in terms of Hollywood film industry and defense industry. And like one of the articles is on the creation of the film Terminator 2, and they used this advanced use of software, which was Photoshop. So it's just kind of looking back and seeing that Photoshop was like this advanced new software to use was kind of funny. So so when I talk about parametricism, by the way, just to be clear, smooth curvilinear surfaces, this is what I'm talking about here. This is like the epitome of parametricism, by Sahadid architects. This is the Haydar Aliyev Center in Azerbaijan from 2012. But I could put any image from this firm here. And just so quickly, looking back, some of what were they talking about in this image? In this issue. One of them was an article by Peter Eisenman, which also looks at one of his Reebstock proposals, which is here for a building. And this is his interpretation of the fold, which is not, I guess you can kind of interpret visually as this kind of literal interpretation of the fold, but really it's about shifts and breaks. I was intrigued with this article by Eisenman because it was the first time I saw an architect talk about this this essay by Walter Benjamin titled A Work of Art in the Age of Mechanical Reproduction. And he talks about it in terms of technology. But he doesn't even, saying how there's no, in this essay, Benjamin notes that there isn't, with technology, say for example, film or photography, this idea of the original, of there being one original is irrelevant. Because, what is the original in photography? Is it the negative? This is even before digital photography, right? 1993. So is it the first photo? is the first photo that's developed really different than the 10th film? So here we're having these forms of art that Benjamin writes about that really has no original. And, you know, there's also this idea of the aura, an aura, A-U-R-A, that is lost in these mechanical ways of reproducing art in this mechanical age. So, but, I mean, there's other aspects, a lot of other aspects to this essay. But I thought it fascinating because I never thought of medium that way. Or, you know, oh yeah, that's right, there isn't an original film. You know, they're distributed everywhere and you're seeing the same exact thing, but these are still works of art. And so Benjamin also talks about what are the repercussions of that. You know, now before you would have a painting and then one or two people can stand in front of the painting or the sculpture, whereas a film, it's like art for the masses, like a whole theater of people can experience a work of art at the same time. And how also writing at the time during, you know, the rise of Nazi Germany, he also talks about how this understanding of new way of art is used to manipulate the masses and so on and so forth. But Eisenman isn't talking about that, but he's talking about this loss of the original. But he doesn't talk about how computers add to this. He talks about the fax machine, which is hilarious because now it's a totally irrelevant technology. But he was saying, like, you know, you have photography, film, the fax machine. And believe it or not, you even talked to Don Bates. There was a time when the photocopier was a big design tool. The architects would use the photocopier, and even some people, there was a project that was designed by fax. So architects trying to push the boundaries of this new technology, which now seems a bit absurd. You have, you know, this chair, one of the, you know, looking at this chair designed by Frank Gehry. Oh, sorry, this is just another image of the Reebstock master plan that Eisenman is talking about, but, you know, in looking at it in terms of, and he's trying to compare it or frame it theoretically looking at Walter Benjamin's essay. And these are just some images. But then when you do look here, you can begin to see this shifting of what was perhaps a Cartesian grid. And this is where I guess it really can apply to Deleuze's idea of the fold here. And so it's, for Eisenman, this is an articulation of the project site that began with 7 orthogonal grids, and then he, you know, shifts them and contorts them to create this project. You can also see here in how he's making the forms of the building by taking a regular parallel pipe, you know, rectangular volume, and then shifting that. And so this is where he's kind of trying to break away from this idea of the Cartesian grid. They have an article on the designs of Chuck Hoberman, you know, these kind of collapsing and opening structures that really don't have anything to do with parametric architecture. They do have this image of the, project of the Frank Gehry and Philip Johnson Lewis residence, which I think in the end was never built. But in order to create this fish here, this is where they're beginning to look at and bring in James Gliff and Rick Smith and others saying, okay, how are we going to manufacture this? And they find a fabricator in Italy, and they do the fish for another project. But it started here. Yeah, I don't know what that image is here. Now, one of the projects that is most relevant for our understanding of parametricism and curvilinearity and smoothness in architecture is this very small article by this Japanese architect Shoji Yo. And this was for a gym project in Japan. And you know, what is interesting about this is you can see here he's using the computer, and it's not just a space, you know, a straight space frame. What the architect is doing, and it's dependent on also, what he's doing is starting out perhaps with the surface, but it's bending and curving according to the program that is below, which is part of this gym. It's a gym and like swimming pool complex. And so this is being parametrically, and the building is all roof. So then when you have this, surface going up and down, that would also call on, the columns having to be also kind of fabricated and at different heights. I mean, it's somewhat reminiscent of this project, and we'll talk more about this in the coming weeks when we talk about spatial composition. But, started out with this kind of structure. This is Mises' design for the National Gallery in Berlin, where it's like all, roof and then columns. But Yo is curving that. It's not just this one cover. It's the roof bends and curves according to the programmatic needs. And here is just another image of that project here. This was a big deal, and this is the only really computer-generated project that's inside the entire issue. Here's a great image showing that roof and how it would go, above the tennis courts. The roof would go down, creating a more intimate space in the locker rooms, and then when you have these big public open spaces, the roof would go up. So these are, parametrically designed roof, and the columns that would go with them. And so you can see this as the basis for what would come a couple of years later with Greg Lynn's animate form, where he's also looking at different models of within not just architecture, but in history of where do you find these kind of distortions or morphologies happening. And actually, I've written to him and asked him, where did you learn about this biologist, Darcy Thompson? And he said, I just learned it when I was in graduate school. But he was looking at here, you could see these are not by Lynn, but in fact, he's looking at the work of this biologist, Darcy Thompson. Or you could say he's like a type of, I don't know if he was a contemporary of Darwin or not, but he wrote this book called On Growth and Form. Hopefully you've already heard of this in your studies. But what Thompson was doing was, not only studying different species and different types of animals, but, he wanted to record them and compare them. So in order to compare them, he needed to kind of start out, and you could see here, he would start out with your very basic Cartesian grid with equal spaces, and then you could say this is a very well-known traditional crab. But then to compare that with a different type of crab, then the grid contorts. And a grid is something you can measure. It's a measurable thing. So this is where you can take something, a form that's smooth, odd-shaped, non-standard form, but once you're always comparing it to a grid, then it becomes measurable, right? We also know that from the Bezier curve. And so Lynn and others, Lynn was not the first, but others are looking at Thompson and saying, what if instead of using it as a means of analysis of non-standard forms, what if we also then use this as a tool to create architectural non-standard forms? Since now we have the use of the computer and different software to create these complex curved surfaces. And then I've already told you he's looking at naval architecture and lofting, and then here this is the curve, comparing the Baroque curve that's based on static geometry, and this one, it's the same exact curve, but it's using, what does he call it, spline geometry. And then it goes on to create these are the embryological houses that were based on this idea of metaball. So I'll just go through this. Now, the thing with Lynn, he's wonderful at theorizing. and also writing about these changes, these shifts in architecture. And actually, you will be doing some reading of Lynn, and we're going to even talk about another article that he's written that uses those Thompson grids. And so, by this time, this is the only real building he had designed in 1997. He was also editing and writing for this journal called Assemblage, and he was he's working in Peter Eisenman's office in New York. I mean, he was very active, but when you want to put the theory and his ideas and the practice, they're not, you're not going to see a lot of building, but he does do other things such as the design teaching. He teaches at 2 other institutions. He was teaching at Yale. Now he teaches at UCLA and in Austria. And he's hired as a consultant for a lot of different companies such as Piaggio. But you can see how, this is the Yokohama Ferry Terminal by FOA, or Foreign Office Architects, and how this idea of a topology in architecture starts to, spread and is being used as an idea by other architects. I'm sorry I don't have the date here, but this is a project that was a competition in the 90s, and this wasn't finished, I think, until 2000 or 2001, many years later. This was an existing ferry terminal that they designed, or it was it was an existing pier, but it was like a ferry terminal that I think needed a redesign. And so here you can see, here's the ferry. And so you would think, the knee-jerk reaction before this was to kind of build a building. And so they said, no, we're going to the whole building, the whole project is a surface. It's this kind of thick 2D surface that people using this space will occupy. And so this kind of horizontality of form is also something, and I'll talk about it more when we talk about fields. There's also idea of the return of the matte building. So here's an example of the thickened surface. Or here, this is Foster's and Partner Airport, where the entire building is basically all roof. The roof is the form, and the roof is all one surface. It's not about the columns. It's just also this column-free, basically, space. It's just building as surface. And so when we're talking about surface, let's talk about this idea of performative surfaces in architecture. One of the most, well-known academics, architects who's kind of brought this idea of performative surfaces into architect is a gentleman by the name Branko Kolarevic. Actually, he lectured here a couple of years ago, but he teaches now at NGIT in the US. And in a book on performative surfaces in architecture, he writes, this is how he describes this idea. The emphasis on building performance, from cultural and social context to building physics, is influencing building design, its processes and practices, by blurring the distinction between geometry and analysis and between appearance and performance. So this is, a new criteria in which to assess architecture that, didn't even exist up until a few years ago. Now, I guess when we look back in terms of, the idea of this performative surface, it has to be this great court of the British Museum by Foster's and Partners, and also a lot of different engineers. This was a courtyard, and the goal was to create this covering to make it like an indoor atrium. But, they wanted it to be column-free, and it would be self-supporting. So you wouldn't just have, before you would have window mullions or some, glass with mullions, and then underneath some type of structure like a space frame that was held up with columns. But, the big step taken here was, no, the mullions holding in the glass is also the structure. I mean, you do have columns, which actually are, this cylinder is basically a double facade, and there are columns that come down here. But these are, like, you know, quite a large expanse here that you wouldn't have it before. Another actually interesting, here are just some images of that. And, you know, you're working very closely with these engineers and this specialist modeling group, and they're mapping, you know, all the stresses and loads. And so this is also not, it's a grid, but it's not a uniform. The members aren't all uniform. Where there's more stress or more load, the beams thicken, you know, and when it needs less, they get thinner. So here the grid is not only moving, but actually the thickness of the members required for the structural load also expand or get thicker as needed. And these are just some images of that. There's just a couple more projects I want to show you. This is a really important one. And I think now and you can see why this is a tectonic issue, but we're talking about this work by the architect and educator Akim Menges. And he has this idea of not just this tectonic that you think of, you know, structure and material merging together. It's saying, no, the tectonic is embedded in the material. The materiality is the generator of the design. And he's looking at, you know, not just the kind of character senses or aesthetic properties or tactile. He's looking at it, you know, the materiality at the level of the DNA of that material. And this is basically his theory, that materiality no longer remains a fixed property and passive receptor of form, but instead it can be transformed into an active generator of design and an adaptive agent of both structural performance and architectural performativity. And I think the best way he shows his theory, he's teaching at this Institute of Computational Design and Institute of Building Structures and Design in Stuttgart. And so these are a series of pavilions he builds with his students. And so it's through designing these pavilions, which again we told you are mostly tectonic, that he's pushing this idea of materiality as a generator of design. And so here is just one of their first pavilions built in 2010. They're looking, not unlike the low-tech, at these, I think, Iranian reed structures, these bundles of reeds, and he writes about how, you know, it's knowing these properties and, you know, the thickness and the number of reeds that you need to bundle together that you get the type of required curve that's needed. But he's even looking at, you know, the DNA closely at the material structure, reading the materials code at the cellular structural level. You know, and so understanding what is the behavior of this wood? What is the behavior of a plywood, or, you know, a cherry wood or walnut in terms of pine, or so on and so forth? Or what happens when you treat this wood with a certain type of laminate, or so on and so forth? So it's really understanding the material, and from that you will get the form. And here are just some images of the final project. So this is what, I don't know what you call these except for structural members, because it's not really a beam, or maybe you could say it's an arch. These are also could only really be fabricated by, that was part of the studio, using this robotic arm. They needed to be, you know, computer automated, because not only would you, the precision that you needed to put this together, but also I think all these members are different. I don't think they're all similar or the same, and that the way they're put together, they also mapped out the different strength, the loads and bearings that were needed, which you can kind of see here. So that was the first one. Then there was another one they did, and this is similar to the box frame of the Serpentine Gallery of Edos, but they used not just these kind of boxy rectilinear forms, they almost came up with this type of pod structure. As you can see here, eliminated the material that was not necessarily needed to make them lighter, but enough to have these being basically, structural integrity. And here you're creating this type of structure that's, never been used before, but it's understanding material and also the way it can be put together. That they're creating this type of structure. Also, they have lighting in that space in the box. So by cutting out parts of the panel that are not structurally needed, they're also using this use of light effect. This is a view from below. I just want to also these are also made in the fabrication lab. Here are students putting them together, but if you see this tongue and groove connection that are not just abutted at 90-degree angles, each side and each surface are, they're chiseled away at a different angle. That's something you can't really do by hand. That's something that you need to be programmed through using the computer and the robotic arm. And here you can see here, this panel, this side might be one angle and another side a different angle, depending, where in that kind of pod-like box frame structure is needed. This is just, again, a mapping of the stresses and loads. And again, this is where a regular drawing doesn't really help us understand the building so much. This is not for humans, really. This is for the computer to understand. I don't know if I have the chance to, maybe we can quickly look at it. But this is just one last image, one last project. It was for an art installation where Menges designed this type of sculpture, let's say, that would actually move. Parts of this would move according to the humidity that was controlled in this box structure. And so the space would, you kind of put some type of mist, increase the humidity in this glass container, and this structure made out of wood would change and move, and some of these scales would open up. And then they would take away dehumidify this container, and then this structure would close and move. I don't think we have enough time to see it today, but I will send the link to see this yourself as an LMS announcement. And I will end my lecture there. Great. Thank you very much. Hi,
how are you?
Good.
Do you have a moment just to have a quick chat about something?
Sure.
I wanted to be able to talk to you about it.
Just right after we get out.
Yeah, that's
Okay.
fine. Sure. Feel free.